Alrighty, friends, we're going to find some volumes. Ooh, as if we have things rotated. How to find area under a curve. So to find the area under a curve, we're talking about Riemann, so that's the summation notation, and FTC, so that's the integral notation. For the Riemann sum notation, I don't know, you could go like k equals 1 to some sort of n, and you have f of xk, delta x, something like that, would be the Riemann sum. The integral notation, sorry, my brain fell out, looks like this. I don't know. So those are kind of your general forms. The Riemann sum, you can manipulate one or the other to, look more like a left-hand sum or a right-hand sum or whatever you need. Now let's consider volume. How can we connect area and volume? Well, when I connect area and volume, I think of geometry. And I think if I want to find, say, the volume of a prism, and in this case I'm just going to make a rectangular prism because who cares, it's fine. I would do the area of the base and multiply by the height, and that would get me the volume. So if I take the area of the base and I multiply by the height, I get the volume. Well, that's the same thing as saying taking the area of the base and add it up h times. And when I say add, that makes me think of the sum or the integral. And for the h, that's kind of like saying the width of the interval. So is it fair to say, if I know the area of some piece of a figure, if I integrate across some interval, that'll get me the volume of that figure? That makes some sense in my brain, so let's see. What 3D shape? So if I take, if I take this right here, and if I spin that about the x-axis, that's going to form, take a piece of paper, spin it about in a circle, that forms a cylinder. Well, I can do geometry. Let's do geometry. So the area of the base of that cylinder, the radius is 3. So the base area is pi r squared, so 9 pi. And then the height is 5. So then the area is 45 pi. But this is a calculus video, so let's do calculus. Hopefully I get to the same place. So my thinking for calculus was I integrate. I'm going to go 0 to 5, because I'm going to think of this as the height of your cylinder. Then the area of the base is 9 pi. So you can either FTC or geometrically do this however you want. So that's 9 pi x from 0 to 5, which is 45 pi. Okay, that matches with the geometry I thought. If I take this figure, it's a triangle, and I spin that about the axis, you should be able to see that that's going to be a cone. So if I think of geometry, so this is a cone, let's think of geometry. The area of the base is again 9 pi. The height is 3 this time. The volume is 9 pi times 3 divided by 3, so 9 pi. So I better get that for the answer. Alright, now I'm going to have to think a little more for calculus. So if I think of this as the height, that's the integral from 0 to 3. But the radius is changing. But this is a line. That's the line 1, 1, 2, 2, 3, 3. That's the line y equals x. So the radius at any place is the x value. So that means I regret writing this here. So the radius is the x value. The area of one of those slices, because remember that's what my goal was on the front page, was to find the area of one slice. The area of one slice is pi x squared. So then the volume is going to be integrate that from 0 to 3 pi x squared dx. Okay, so we can FTC that. That's pi 1/3 x cubed from 0 to 3, which is 27 divided by 3, which is 9 pi. Oh, that's what we got. That's what we started with. We wanted to get. Okay, so that one we had to think a little bit because the radius was not a fixed number as it was in the first one. It was a expression. for this one, if I take this little region and I spin it about the x-axis, that's going to remind me of like a Hershey Kiss type shape. Or sometimes I talk about there's this place in Pennsylvania called Wilbur Chocolate. So they have Wilbur Buds, which are like Hershey Kisses. But they're better. Shh, don't tell anyone. But I can do this, and so I can't do this using like my geometry formulas because this is not kind of one of those 3D figures that we had in geometry. But I can do it using that same cone idea. So it's like a cone. So is it fair to say that the radius is whatever this curve is, and it goes through 1, 1, 2, 4. That looks like x squared. So that means the area of one of the cross sections, one of those slices, well, we're spinning this, so these slices are circles, so it's pi x squared squared, so pi x to the 4th. So then the volume we integrate from 0, in this case it's 0 to 2, pi x to the 4th dx, and that's going to be pi 1/5 x to the 5th, 0 to 2. So that's 32 pi over 5. That says 32 pi over 5, believe me. All right, this one is different. Let's think about this. Let's think of the teal one first. So the radius there is whatever this curve is. This curve is the square root of x. If you can't recognize it, that's okay. So for this one, the radius is the square root of x. The area of one cross section. So if I took this and I spun around in a circle, oh, it's still a circle. So it's just pi x squared, or pi square root of x squared. So it's pi x. So then the volume is integrate from 0 to 1 in this case, pi x dx. But we also have, get rid of this, we also have this other curve going on. So if I take the other curve, that's x squared again. So the radius is x squared. So the area is pi x squared squared. So the volume is integral 0 to 1 pi x to the 4th dx. Now, to find the overall volume, let's see. This volume is going to be smaller than this volume. I know I'm just showing area, but pretend I'm spinning that. So if I subtract that purpley from the teal, then it'll work. So if I take, and I can integrate this together. So if I go 0 to 1, and if I take the big one, which is pi x, and I subtract the little one, which is pi x to the 4th, that should get me somewhere. So that's going to be pi 1/2 x squared minus pi 1/5 x to the 5th from 0 to 1. So that's going to be pi over 2 minus pi over 5, which is 5/10 minus 2/10, so 3/10. So I found the volume of the outer piece and then the volume of the inner piece, and I subtracted those things. I said inner piece. Because if I subtract the inner part from the outer part, I think of this in terms of like a woodworking project where I'm cutting a hole out of something with like a drill or some other tool. So volumes by discs or washers. So discs are the solid ones, washers are the ones with the hole in it, because a washer looks kind of like this. Obviously it has some thickness, but that thickness is the dx. Generally, what you're doing, you want to find the radius. So find the radius. You then, or 2, because for washers you might have 2. And then you find the area. I forgot how to spell find, apparently. Find the area, or 2. And then find the volume. You could say or 2. You can do those volumes together. You could subtract the things together inside one integral. It doesn't matter. So find the radius, find the area, find the volume. Don't forget the pi radius squared idea is your area. And then your volume is your integral from a to b, pi radius squared. Now sometimes if you have two radii, like in a washer, sometimes you'll call it big R for the outer radius and little r for the inner radius. And you'll have pi big R squared and pi little r squared. And then for the volume, you'll have pi big R squared minus pi little r squared. You could take the pi out. It's a constant multiple. You could do this as two different integrals. That is allowed. But that's kind of an overview of what's going on there. Now is when things get spicy. So we're going to rotate around y equals negative 2. Let me draw that in. So y equals negative 2 is down here. And what we're rotating is this thing here. And if I were to rotate this about y equals negative 2, there'll be this gap right in here. So I can think of that as a big gap here. I can think of that as the inner radius. So the inner radius, which on the previous page I called little r, is 2. And then we also need to find what big R is. So big R is the distance from here up to the curve. So that's going to be 2 plus the equation of that curve, which is x squared. So let's take a look at that in case that part blew up your brain a little bit. There's the y equals 2 line. There's the y equals 0 line. And here's the x squared curve. So for each of these pieces, we have a green piece, and then we have the purple piece. So the green piece is always 2. And then the purple piece is the equation here. It's the y value of that equation, so that's x squared. So 2 plus x squared is what that radius is. Now, if you're telling yourself, do we really need to care about this 2 plus thing? Yes, because if you think about a point traveling around, if I do 2 plus something, I'm out here and I'm traveling around, versus if I'm just traveling around, I forget the plus. So it's a shorter distance if you don't do the 2 plus, which means you have a lesser volume. All right, let's keep rolling. So the area of the big one is going to be pi 2 plus x squared squared. The area of the little one, I'm going to write above it, is going to be pi times 2 squared. So then the volume is going to be the integral from 0 to 2, because those are x values, 0 to 2. The big area, 2 plus x squared squared, minus the little area, which is pi times 2 squared dx. I'm not going to actually do that all out. You're welcome to do that all out. I'm not going to do that all out. Ask me about it if you get stuck. Next one, again, we're going to rotate about y equals 2. So let's go ahead and write that down. Negative 2, sorry. And that's somewhere down here, not to scale. So again, we have an inner radius and an outer radius. But in each of those, we have a green part. And then, say, we'll have a purple part. Or we'll have a teal part. So the big radius is 2 plus the teal part, which is the square root of x. And the little radius is 2 plus the x squared. So the area of the big radius, that's not what I wanted, wrong color, silly. The area of the big radius is pi 2 plus the square root of x squared. And then the area of the little one is also pi 2 plus the square root of x squared. And by square root of x, I mean x squared. Whoopsie poopsie. X squared. There we go. So then your volume is the integral from 0 to 1. The big one, pi 2 plus the square root of x squared minus the little one, pi 2 plus x squared squared. Don't forget a dx right there. Again, I'm going to think that you guys can do this. I'll give you the answers. This one's 49 pi over 30, according to the calculations that I have made. And the one over here got 256 pi over 15. If you disagree, by all means, talk to me. And let's see, if we rotate about x equals 0. Ooh, that's spicy. So that's like this. So we're rotating this around that. So, okay. This was the equation. Y equals x squared. And when we spun things around the x-axis or around a horizontal axis, we did things dx. Since we're spinning things the other way, we're going this way, we're going to do things dy. So I'm going to go ahead and solve for y. And that's the radius. The radius is the square root of y. The area, therefore, is pi square root of y squared. The volume is going to be the integral from 0 to, let's see, think you can predict what it is? 0 to 4 pi y dy. And I'm going to believe you can do that. Also, I'll give you the answer at the end there. This one's going to be the same idea. Let's go ahead. Yeah, we'll do the outside part first, because that's going to be the square root of y again. So that's going to be, I'm just going to jump down here, 0 to 1 pi y. The reason being, the radius is the square root of y. The area is pi y, because it's pi square root of y squared. Square root of y squared is y. And the other one, same idea. This distance here, if you're confused about this y thing, maybe this will help. This distance here is x. It's how far things are. But x is equal to, in this case, it's, oh, I gotta go here. Y equals the square root of x. So x is y squared. So that means the big, I labeled that wrong, I'm sorry. This one before is the big radius, not the little radius, because it's farther away from the vertical axis there. And then this other one is the little radius. The little radius is y squared. The area of that is pi y squared squared. So minus pi y to the 4th dy. Okay, I'm going to give you the answer, so make sure you've done them. Did you? I hope you did. This one is 8 pi. And this one is 3 pi over 10, according to what I just did. Keep in mind, I'm going 0 to 1 still, because that's this distance, not this distance, the y distance.